I speak today, I'll try to cover and give you an insight into the thinking that has gone in McAfee around cloud security. I would also be presenting what McAfee has been working on and is planning to work on in the cloud security space. So as part of my presentation, you would see me referring to McAfee products intermittently, and although I'll try to keep it as generic as possible and talk in general about security solutions, not very specific to McAfee product. But there is a section when I'll go probably a little deeper into what McAfee offers. I'm Praneeth Khare. I'm Director of Engineering at McAfee. I work out of Gurgaon office. I'm part of the Endpoint Security BU and primarily focus on the next generation data center product suite. And in fact, a number of solutions that I would be referring to today are primarily built out of India, and the teams are divided between Gurgaon and Bangalore. So this is a slide I think most of you would already be aware of, and I think my colleague Siddharth, he's probably not here yet, but he also made a presentation today morning, and he also described a slide very similar to this. So irrespective of whether you are a CIO at a large enterprise or an IT administrator at a small to SMBU kind of an environment, this is what has governed your life in the last 5 years, especially the IT life. You have gradually moved away from servers where you had full control over the hardware, the OS, and the application stack that you were running. You moved into an environment where you first gave up control on the hardware via the hypervisors, and now you are moving into a more public-private cloud where you are even giving up the control on the hypervisor as well, and in certain cases on the software services that could run on that stack as well. One thing, as I speak today, I'll be referring to virtualization a lot, and that's because it's very hard to find clouds in today's environment where virtualization technology isn't at play. So for most of the fact, it would be true that cloud is equivalent to having virtualization in place. So, and if we talk about security in the cloud, it won't be complete unless we talk about how to secure virtual infrastructure or the virtual environments. So continuing in terms of where I was coming to, you are giving up control over the server environment, over the hardware, the software. As more and more cloud deployments happen, the part that you continuously manage is shrinking. So in the packaged software stack, you had the entire environment under your control. Whereas when you go into infrastructure as service, you give up control of the networking, the storage, the servers, the virtualization, and you only manage the applications, data, and the runtime environment. But when you go into a platform as a service, for example, some of the Ruby on Rails servers that probably manage your applications, then you give up control on that as well and only manage your applications and data. Going next is essentially the software as a service environment where, like for example, a Netflix kind of an environment where you have the entire dependency on Amazon S3 and stuff. You are kind of, again, limited in terms of what you could control in that environment. So this slide is a little dated, but the facts are still true. The public cloud adoption is growing, although most of the cloud implementations today are actually private clouds. And the number of VMs in the public cloud are projected to grow at an annual rate of 76%. That means more and more people are eventually gonna move to cloud, and the technology will actually provide the accelerator to move in that direction. So at McAfee, we decided last year that we want to do something specific around this area, what we call as the data center server security market, which includes the cloud. And before we did anything, we decided to poll the market and go talk to the analysts, go talk to the customers and figure out what they really need in this space. What are the challenges that they are facing? And here is what we found. So there is indication that the private cloud is getting adopted than public cloud, and at least in large enterprises. So people are still not very keen to go on the public cloud infrastructure, but they are willing to take on the private cloud infrastructure in their own enterprises and implement it there. Enterprise IT is very much interested in a cloud infrastructure as service, but they are not willing to do it right now. And although we expect that the public cloud adoption will go up. Another interesting fact that we found about cloud adoption was that majority of the workload is currently running Windows, almost like 2/3, closely followed by Linux. But the interesting fact here is that now we are seeing a lot of Linux VM adoption going up, and the reason for that perhaps seems to be the licensing cost associated with Windows, and people are much more comfortable expanding their workloads on Linux. The server security market size is growing about 6.6. Another interesting point is the next bullet, which talks about the server spend per server is increasing. But that's actually happening in the future server security space, and where people are asking to protect the virtual environment. So people are not willing to pay you more for just protecting the endpoint, but they are willing to pay more if you have a solution which is optimized for virtual environments. And again, which is true for virtualization, which is the operational efficiency and the cost efficiency is the primary driver for being the cloud adoption happening here. And the last point, people still expect they would have a combined and a secure virtualized server, so they'll have a integrated management. It's not that they're going to move away from physical servers for now, so they want a unified management approach for both physical as well as virtual servers. So from the data center perspective, what we found was that the customers, so most of the on-the-shelf products, they don't really meet their requirements because they are not optimized for the virtual environments. So people are not finding them scaling as fast as they would want it to. The on-demand computing also puts a lot of pressure in having the constantly updated online images. For example, again, let's take the case of a Netflix. So if I'm seeing a lot of traffic coming from a specific country, I need to handle the load in a virtual server, or the virtual machines that are closer to that environment. If I need to spin off those machines, I'll have to ensure that the security patches are updated on that environment. And as a result, I need to think of even some offline update mechanism for if I put a traditional security solution in there. I think we can probably skip the rest of the stuff, but the fourth bullet there is where the data center is going to be a blend of physical and virtual infrastructure in the near term. So it's not that people are moving into complete virtualization as yet. What we checked in almost like 2011, there were 40% of the servers were virtualized, and that is expected to go up to 75% by 2014. So the key takeaway, so if we look at this and understand what the market drivers are, what kind of solution are they looking for? So they need offloaded agentless security wherever possible. They would want to use the facilities provided by the infrastructure as much as possible with minimal load to provide security at par with the physical environment. They need efficient and elastic security because the advantage of having a virtual infrastructure is that you have the flexibility. You have the flexibility to move loads around, load from one hypervisor to another depending on how it is loaded. So they need security policies to move along with them. Then they also need, because if you move into the cloud infrastructure, you lose even the control of the hypervisor. So they need a proof that what you are running on is actually secure and you can trust that. So they need some trust attestation piece there. They also need that when some of the loads are running, they have runtime protection or runtime integrity assurance provided at that point. In terms of management, they look for a single console in the entire data center. They don't really need a separate console to manage virtual infrastructure and another separate to manage the physical one. And they need integration with the security of the virtual ecosystem console, which means, for example, if you have a VMware vCenter, they would need integration capabilities to that. So on the basis of that, we worked on a number of solutions, and I'll go and describe briefly in terms of what and how we are achieving some of these requirements that we saw from the market. So let's take the case of how you would want to secure the data center. So this is the case when you have the physical servers, and how would you typically go and deploy security. So you go and discover what the machines are, you do the discovery part first, you push your agent, in this case I'm specifically referring to McAfee agent, which goes in all the physical servers, and then you can start deploying the security blades. Now security blades are something which will, depending on what you really need on those servers, like for example AV is a blade, HIPS is another blade, IPS is another blade, maybe web protection is another blade. So that way, depending on what you need, you will then start provisioning these blades onto these servers. And then you have this McAfee EPO, which is the central management console, to manage it. Now, if we take the case of a virtual infrastructure, we have a virtual server farm. Now, we could go and still discover the VMs as we would discover the physical machines. But there is one thing very different in the virtual infrastructure is that these are different from the physical machines, and they have properties and attributes which is important to understand from a virtual optimization point of view. For example, I could have VMs running on a single hypervisor. So if I load all those VMs in a particular way, my hypervisor load will go up. Similarly, these VMs may be connected to the same storage at the backend. So depending on how or what kind of configuration I need, I may want to configure security in a different way. So, and similarly, I mean, this is just the case of a private cloud, but this could be a public cloud as well. So for example, I could have a Amazon AWS capability, and I would want to discover what all VMs I'm actually using from that environment, what kind of security posture do they have, what kind of protection can I provide on them. So now when we discover that, okay, these are the VMs, whether these could be the VMware VMs or the AWS VMs or any other private cloud, like for example, the HP cloud that you want to use. So once we discover that it's a VM, we would now start deploying the security. And once you have virtual machines, the preferred mode of protection is agentless, which is what people expect, that there is no agent available on those machines, but you still provide the same level of security as you would on physical. The reason people are not comfortable putting on physical agents on these machines is because they think it will reduce the efficiency and have impact on the performance. So, for example, now if I have to implement, let's say, an agentless firewall or an agentless antivirus on this, the way I will do it, I'll explain it in terms of how we do it in the case of a AV system. So, in case of, we have to provide capability to do malware scan. What we do is we deploy another SVA, which is called the security virtual appliance. This is nothing but a separate VM. And what we do next is we provide a, sorry, that's not here in the animation, but so what we then do next is we use the capability provided by the hypervisor vendors, like for example, VMware, which provides security hooks into the hypervisor itself, that when a VM is accessing a file, you get a trigger on the SVA to go and scan that file. So we use that capability to provide agentless scanning. So anytime a file gets scanned on a particular machine, let's say VM1, we'll get a trigger on the SVA to go look up that file, do the local engine scan, use the DAT and everything, and provide a result back to the originating VM. And accordingly, the VM could let the file go and execute on. So this way you achieve the same functionality that you would have if you had the local AV on that machine. Now this has added advantage, because now if another VM, which is let's say VM2, tries to access the same file on another VM, we would again go and try to check the cache into the SVA. And since it was already scanned, we will have the result available there. So that way you also avoid the scanning. So this is also helps in scan avoidance, and it helps you actually have much more efficiency and flexibility in that sense. We then maintain the local cache on the VM as well as the remote cache on the move scanner. So now, when we have this scanner, we can augment this cache by having what we know as the local threat intelligence. So this is nothing but in terms of, like for example, if I have a file which is signed by a trusted publisher. When I say trusted publisher, I mean vendors that you would trust, like for example, Microsoft to provide certain services. So you can actually avoid scanning those files altogether because they are signed. If they are not signed, they would get a scan. So all those kind of intelligence you can build, and you will build a cache on the basis of whether they are scanned, they are already known white in the sense, you trust them to run in your environment. And then we augment this data with GTI service. Now GTI is the Global Threat Intelligence Service, which McAfee provides. So this is a database that has been built over several years, and it is a list of known good files, known bad files, and it is constantly updated every hour, every minute from different locations. So depending on, like for example, if you have a malware being reported from one location in India and a similar kind of a malware being reported from another location in China, so this GTI will catch this information and then populate the rest of the environments, that anytime you see this malware, stop it right then and there. So this also helps in the detection efficiency. The other thought would come, okay, so now is this kind of an environment only true for the physical or so the virtual infrastructure? But it can also be applied on the physical infrastructure as well. There is no limitation on why this cannot be used in a physical environment as well. So what we do is, instead of having the regular AV agent or the McAfee agent on each of the endpoints, we deploy a small agent, which we call as the move agent, which does the exact same job of offloading the scan and maintaining the local cache for providing you better optimized performance. So this way you have, whether you use it on a physical environment or a virtual environment, you get the same level of security with a lot of flexibility. Now, okay, I have deployed security on a lot of virtual infrastructure servers, but let's look at what happens when a virtual server has to move from one hypervisor to another. And that's where this elastic computing comes into picture, and we provide the elastic network security. What that means is, depending on load or a policy, when you move or migrate a VM from one hypervisor to another, depending on if you don't have the right security policy on that VM or on that hypervisor, we would actually spin off a new SVA. So this is like carrying your security policies from one hypervisor to another. So you can do all the migrations that you want without worrying about the security postures in your network. So it will be our job. So our SVA would track that this VM is actually moving from one hypervisor to another. It will trigger the central console, which is the EPO, to configure the right policy on that hypervisor and spin off a SVA to handle the security policies from then on. So over here, I'll shift gears a bit and now talk about a different type of protections. So we just covered what we call the bread and butter kind of a protection, which is, I think everybody would understand, yeah, if I'm running a laptop or something, I'll have to have a protection, and typically antiviruses come into picture. If you're an enterprise, you would probably look at a host firewall as well as perhaps a web protection in terms of, like, say, we have a product called Site Advisor, which provides you URL-based protection. But what about more serious kind of threats? What about zero-day attacks or APTs? And APTs are, I think, reality now, and they are over time becoming more and more complex, and they are written in such a smart way that they use sophisticated methods to avoid the detection that typically the antiviruses will be doing. And so this is where we have the protection technology, what we call as the application whitelisting technology. If we look at blacklisting or the AV is essentially a blacklisting solution. It says that I know who are the known bad people in your environment. It primarily depends on a DAT file and certain heuristics to detect that what is wrong in that environment or what is wrong with that program, and accordingly it will flag and detect something as a malware. Whereas application whitelisting is just the opposite. It's just flipping the bit around and saying I would only let the known good stuff run, and anything else that is not in the known good list, I would not let it run. And this gives you protection against zero-day attacks. In the AV technology, or especially in the application control technology, the product that we have is called the McAfee application control. It has some sophisticated techniques like memory protection, which kind of ensures that if you have a whitelisted binary that is running, even if there are vulnerabilities in that product or in that, let's say, Apache or Adobe, we would not let anybody exploit it. So we have certain memory protection techniques which will prevent that from happening. And it is a very effective solution in preventing the zero-day attacks. And how it works is, so you have the preparation stage where you actually create the inventory. This is what we call as creating the golden inventory for your system. So you run the enable task, it will create an inventory of your system, which you can then look and review and finalize, okay, what is the gold? So you can actually do all the scans. So while it's creating the inventory, it will also go check against the AV engine to find out if it is a known malware or not at that point in time. It will also do the GTI lookup to figure out if this application has a bad reputation in the cloud. So if it is clean and it is known good, then only it will add it to the whitelist. And then you enable control, which is saying now I have established my gold or audited image. From this point onwards, your entire system is completely locked down. It cannot be changed. So any of the binaries that are already exist, they would be allowed to run, and nothing else would ever be allowed to run. And even programs that want to update this whitelisted files or whitelisted binaries, they would be denied. So once we have the solidified disk image, but then there are also, the reason why we call it the dynamic whitelisting is because we have certain mechanism by which we can actually dynamically update the whitelist. And so you have the solidified production mode, and you can have real-time continuous solidification. Like, for example, if there is a Microsoft patch that is coming in and that is trusted to be clean, it would be installed and it would be able to change the binaries that you wanted. So this provides a very controlled way of ensuring that the machines that you have are completely locked down and there are no break-ins that can happen on these machines. But there are various ways in which you can update the software. So this is about, okay, so you have the lockdown machine, but what if I want to actually make certain changes on my machine? So there are trust models you have. You could have a time-based change window or a service desk ticketing integration. For example, you could actually have a remedy integration where you can say, okay, I want my system to change or apply this patch. You can even upload the file manifest, and only those changes would be allowed to go in. You would, at the end of the patch cycle, you will get a report that will clearly say you allowed X, Y, and Z, but the person also changed X, Y, and Z and along with A and B. So those would be immediately flagged out, and in fact, those changes would not have even gotten in, but they would be flagged as this person was trying to change A and B. Similarly, the authorized third-party agent, BMC, SCCM, or TBLE that you can configure to be as updaters, which will make valid updates to your system. Then you can have the authorized administrator. It's like saying a user-based policy where you want certain users to have capability to change your system. And then you have also, in certain environments, there are network shares from where people typically deploy software. So you could configure those as certain updaters. And similarly, you could have, like for example, if I have some of my own custom apps, I would want to have capability to install certain applications provided they are signed. And this year we also introduced another feature called the self-approval, where for certain specific users, you could also create policies which will say, okay, these users I trust, and I would want them to make changes to their system. So those kind of controls you can have. So we talked about blacklisting, whitelisting. If you look at it, and especially in the IT world, nothing is complete without a little bird. So that's a lot of security in the context of having blacklisting as well as whitelisting. But there's no point in providing security on the servers if we don't let the person do his usual business work that he needs to do. So how do we do that? We have a workload security posture. So imagine a world where you had all this technology at your hand, and you could dial up the level of control you want to have depending on the workload and the flexibility that you need in those environments. For example, you could have a system or a server where you don't expect a lot of changes to happen, and probably you could completely lock it down using the application control piece. If you have a machine where some changes can be done, so maybe you would want to run application control still, but you will define the right policy updates. If you have a desktop machine where you really don't need to lock it down because you expect users to install a lot of software there, you could probably still have AV as the predominant security solution, but still have application control govern the critical systems file, or for example, the Windows directories and stuff. So this is about, you want to have security, but configure it the way you like. So this is what McAfee offers, a complete flexible security posture. And in fact, some of the other techniques that you could use, like for example, now you have the application whitelisting. So if there are any gray apps, like for example, this is not a known good or not a known bad, but what happens, so I know, okay, known good can be run, but known bad cannot be run. So this is very black and white kind of a distinction, but what happens to gray applications? So this is let's say a new application that has just been launched, or probably some of your custom developed apps which the GTA cloud is not aware of. So how do you provide protection against those? So you could have the HIPS firewall policy configured in such a way that it allows the outgoing connections only through the whitelisted apps, but not through the blacklisted and the graylisted apps. So it's great. We talked about protecting the OS, protecting the applications. But now, especially in the cloud environment, how do you trust the hypervisor and the underlying hardware? And especially if it is in the public cloud area, in the private cloud, you have control over what technology you are using. But if it's a public cloud, you don't even control the hypervisor. So how do you control and how do you ensure there is an adequate security in that space? So that's where we are working with Intel, who is our parent, to utilize their trusted execution technology, in brief called as TXT, to be able to attest the hardware. What this really works is, the way it works is, the TXT allows certain parameters of the OS to be measured and recorded into the hardware registers, which nobody can manipulate. Only the processor has control over what it is measuring and how it is measuring and storing in such a way. So for example, you could measure the BIOS and store it in the TXT registers. Similarly, you could also monitor the MBR and make a record of the hash via this processor registers and record it there. So then we also have the root of trust attestation server, which would have the recorded values or the right set of values for these hashes to be there. So when you eventually boot up, on every boot, the hardware will calculate these for you, and when the application comes up, it can actually go and look up these values via the trust attestation server, whether they are at the right parameter or not. If they are not, there is something wrong in the hypervisor or the way it has booted up. So for example, now let's take a case when we have a technology available and we have the TXT available on all these machines, we mark them all as trusted. And we have the PCI requirement on the VMs that I'm running. Certain VMs can only run on the trusted pieces as well. I mean, the hardware has to boot up rightly in those environments. So let's say one of the servers doesn't have the right set of trust attestation piece. So how it would work is that root of trust attestation server would mark it and the EPO to flag it. And all the VMs that are there on those environments which has a hard deadline or a hard guideline of running only on trusted hardware, they would be automatically migrated via the McAfee EPO to a server which is still trusted. So this way you have continuous trust availability in your environment, and it will work across hypervisors. Another interesting piece that we have is the Deep Defender. This is another piece that we developed or co-developed with Intel. This is currently limited to work only on physical hardware, but we are working with the hypervisor vendors to make it available on virtualized environments as well. So the way it works is it actually sits in the Intel VT layer. We have a component in there which can monitor events outside the OS. So it is independent of what OS you are running, but it can monitor the components that are within the OS. So it gets an outsider view of what is running into the system. And this is very proactive in detecting against rootkits. Rootkits are essentially malware which actually hides its deep within the OS, and it even masks itself from the OS detection triggers. So this technology is a great way to protect against rootkits and a great defense against zero-day attacks. So we talked about a few different security solutions today and the approaches that we could take into the data center, but it is hardly complete because there are a lot of possibilities. Like for example, when we discover the VM, we could dynamically figure out what kind of workload is running on them. Like for example, it could be a web server, it could be a database server, it could be an email server. And then depending on the workload that you are running, we could configure the right security posture as well as the right security products that you need on those environments and configure the right policies for it. So for example, as a base, we would provide the application whitelisting. Then in order to provide for content, because application whitelisting typically works just for application. For data files or PDF or Word documents, you would still need the blacklisting piece. Then you have the memory protection piece, which will provide you complete protection against vulnerabilities. And then depending on the kind of workload you have, like for example, for the web, automatically the right policies and the right products would be pushed, which will provide the firewall and the cross-site scripting protection. Similarly, for the database, we have the database activity monitoring or the DVM or the database vulnerability manager. Similarly, for email, we have email security. For file server, we have AV for storage as well as SharePoint security. And then on top of it, you can have a configuration assessment, which is just ensuring continuously that you're meeting the compliance requirements. And you can achieve that via the file integrity monitoring piece as well. So this is just to give a picture of the whole security suite that McAfee has in the data center universe. So one thing we have to remember is that virtualization is not a one size fits all kind of a solution, and every business would have a different set of requirement and would perhaps be implementing it in a unique way and probably via multiple vendors. So at McAfee we decided to come up with a product suites which we call as the security integrated piece, which is providing security from within and through the different pieces of a virtualized environment and have a very robust solution, especially in the data center piece. So with this, I cover my presentation. So that's I'm open for questions if you have. Thank you.
Thank you very much, Mr. Khalid. Are there any questions? It was a very complex topic, so there have to be some questions. Then there's one here.
In the context of TXT, you said the moment one hypervisor is detected as untrusted, EPO would come and then move the applications to a trusted domain. How does it practically happen? If you're using say VMware, does it in turn use vMotion and then move the apps?
Right. So basically, we have integration with the vCenter, via which we will trigger the depending on the policies that you have. Like for example, you specify the workloads, and these VMs are also via the vCenter integration also populated in the system tree. I would say, which is a very similar concept where we list down the entire network infrastructure in terms of what machines are there, what kind of workload is running on them. And then depending on the policies that you have, we would actually detect, okay, these VMs are existing on these hypervisors, which is now has been detected as, let's say, not booted correctly, or there is a security hole in that. So we would request the vCenter to trigger the movement via vMotion to another hypervisor. That's correct.
There is integration.
Yeah, so there is integration via EPO, right? So that's what I said. I mean, from the customer point of view, they also look for integration with vCenter, and like for example, if you have the Amazon AWS client piece, so they also need integration there as well.
Thank you very much. Are there more questions from the audience?
You have put so many checks and balances to secure the system. But about the performance of the server, how much percentage to degrade the performance of the server? Because once you load any of the antivirus, it degrades sharply the performance of the server. Sharply.
Yes.
So what about this?
So basically, yeah, so that's what our the McAfee optimized solution for virtual infrastructure, which we call as the Move AV. It really has a very small agent. It's not the heavy. So basically, when you put a security solution like an antivirus on an endpoint in a virtualized environment, the reason why you have a lot of load on this machine is because you have the entire engine piece running there along with the big DAT on that machine. So every time
on the enterprise, once your McAfee server is installed in any of the organization, and only client is running on the PCs, even though your machines get slower.
Right. So that's what I mean. So I agree there is a performance impact with the AV.
So what is the percent of degradation of performance as compared to, suppose the machine is running on 100% after installing all these tools, what will the performance? What is the factor?
Okay, so yeah, that's actually part of our. I mean, if you look at our data sheets, it kind of covers it. So for example, if you have all these solutions optimized, I mean, for the data center running on a machine, so the server degradation is expected to be around in the 10 or to 12% kind of a range, if you have the optimized data center suite.
Are there any more questions from the audience? This one.
You told that you are developing a code and you will use Intel VT technology and you will see an application that will run from the processor end. But can you see the scope that any cloud computing provider will provide that you can run that McAfee solution? They will say it is our proprietary, it is our hardware. We can't run any application on the processor level. We will give you the hardware level, we will give you the server level, we will give you the application level, but not the processor level. What you can say about that?
No. So basically, along with Intel, we are working with a number of hypervisor providers to provide a technology which is called nested virtualization. So we are gonna have, like for example, the technology that I referred to as Deep Defender, we are gonna have it available on the virtual infrastructure as well via the nested virtualization piece. So it would have one level of virtualization provided via Intel hardware, the next level of virtualization provided by the appropriate cloud vendor. So we'll have our piece in there. So we are working with close collaborations with certain hypervisor vendors on that.